Welcome to our final lesson of JSS 2 Basic Technology, Revision and Design Project. In this lesson, we will review all the major topics we have covered this year, and then we will walk through the design process for a simple project that brings together many of the concepts you have learned. Let us begin with a revision of the key topics from all three terms. From first term, we studied technical drawing, which included orthographic projection, the system of showing 3D objects using front, top, and side views on a flat surface. We learned that Nigeria uses first-angle projection, where the side view is to the right of the front view and the top view is below. We also studied isometric drawing, where 3D objects are drawn with vertical lines staying vertical and horizontal features drawn at 30 degrees. We covered precision measurement with the vernier caliper, accurate to 0.02 mm, and the micrometer screw gauge, accurate to 0.01 mm. We learned how to read both instruments correctly. We studied joining metals through soldering, joining with low-temperature solder alloy, and welding, fusing base metals at high temperatures using arc or gas welding. We covered properties of materials including strength in its forms of tensile, compressive, shear, torsional and bending strength, hardness tested by Brinell and Rockwell methods, and other properties including elasticity, plasticity, ductility, malleability, brittleness, and toughness. Finally, we studied processing of natural materials, covering how iron ore becomes steel in a blast furnace, how bauxite becomes aluminium through electrolysis, how timber is seasoned, how cotton is processed into fabric, and how crude oil from the Niger Delta is refined into petrol, kerosene, and diesel. From second term, we studied electrical circuits, the difference between series circuits where components share voltage and a single failure stops everything, versus parallel circuits where each component gets full voltage and a single failure does not affect others. We studied Ohm's law, voltage equals current times resistance, and learned how to calculate voltage, current, resistance, and power. We learned about electronics, diodes that allow current in one direction only and are used in rectifiers and LEDs, and transistors that amplify signals or act as switches and are found by the billions in every smartphone. We covered plumbing with its pipe types, GI, copper, PVC, PPR, and fittings including elbows, T's, reducers, couplers, and ball valves. We studied concrete, its ingredients of cement, sand, aggregate, and water, its mix ratios, the importance of curing, and how steel reinforcement gives it tensile strength. And we studied brickwork and masonry, sandcrete blocks, mortar mixes, bonding patterns with stretcher bond being the most common in Nigeria, and the importance of damp-proof courses. From third term, we studied mechanisms, gears with their gear ratios converting speed to torque, and pulleys with their mechanical advantages for lifting loads. We covered energy conversion, how generators use electromagnetic induction to convert mechanical energy from steam turbines, water turbines, or diesel engines into electrical energy, and how Nigeria's power stations at Kainji and Egbin fit into this picture. We learned about computer-aided design as the modern replacement for hand drafting, with its advantages of accuracy, speed, 3D visualization, and integration with CNC manufacturing. We studied maintenance of tools, preventive versus corrective maintenance, specific care for cutting tools, measuring instruments, and power tools. And finally, we examined technology and the environment, the benefits technology brings and the environmental cost including oil pollution in the Niger Delta, air and water pollution in cities, deforestation, and plastic waste. Now let us walk through a simple design project that applies many of these concepts. Project: design a simple tool cabinet for a school workshop. Step 1. Define the problem. The school workshop needs a tool cabinet to store and organize hand tools, chisels, hammers, saws, and screwdrivers, so they are easily accessible, protected from damage, and can be quickly checked at the end of each class. Step 2. Gather information. How many tools need to be stored? What sizes are the tools? How much space is available? What materials are available? What tools do we have to build the cabinet? What is the budget? Step 3. Generate ideas. Sketch several possible designs. Consider a wall-mounted panel with hooks and clips for each tool type. Consider a freestanding cabinet with drawers. Consider a mobile trolley. Step 4. Select the best design. Choose the wall-mounted panel because it displays all tools clearly, makes it easy to see if any tool is missing, and is simple to construct. Materials: plywood for the panel, mild steel hooks and clips for the tools, pins for protection. Step 5. Make detailed drawings. Draw the front view, top view, and side view of the tool panel using first-angle orthographic projection. Specify all dimensions. List all materials needed with quantities. Step 6. Make the project. Cut the plywood panel to size. Drill holes for the mounting screws. Attach the hooks and clips. Paint the panel and mark the outline of each tool on the panel so you can see immediately if a tool is missing. Mount on the workshop wall. Step 7. Test and evaluate. Does the cabinet hold all the tools? Are the hooks strong enough? Is the panel mounted securely? Is it easy to take out and return tools? What improvements could be made? This design process: define, research, ideate, select, draw, make, test, is called the design process or technology process, and it is the foundation of all engineering and product design work. Congratulations on completing JSS 2 Basic Technology. You have covered a wide range of topics that introduce you to the world of engineering, construction, electricity, and design. As you move into JSS 3 and beyond, these foundations will support your deeper study of technology subjects. The skills and knowledge you have gained are relevant not only to your examinations but to your future careers in Nigeria's growing technology sector.